Hello guys and welcome to your next tutorial on GNU Simulator. Today we will discussing about the registers and flags we use. Basically we're gonna use in this tutorial. So the registers A, B, C, D, E, H, L are we gonna basically use it. A stands for accumulator, where the basic addition or subtraction or any operation will be performed there. BC is the register pair, where this two zeros signifies for B and this is for C. Similarly D, E, H and L. Now PC stand for program counter, where the next executable program's address is stored, and SP is stack pointer. We generally not gonna discuss it about, because we are not gonna have to use this so much. So let let's move on now about the flag. Where what is S, Z, A, C, P and C? So SS signifies the sign bit. Remember, when you just imagine that accumulator stores negative data, negative bit, or negative data or input something. So when negative input is there, the sign bit is changed to 1. That means it signifies accumulator content is negative. Similarly, Z stands for 0. When the content of the accumulator is 0, it signifies 1, and when it is not 0, then it signifies 0. Now AC stands for auxiliary carry. What is auxiliary carry? It is, just imagine that you are adding to 8-bit numbers. So when you are adding to 8-bit number, suppose in third bit or in fourth bit there is a carry generated. So that carry is stored in AC. So it signifies AC stores the carry which is generated internally. P stands for parity. When the accumulator content have the even number of zeros, then it is 1. That means the parity is even. And when there is odd number of zeros, then the parity is 0. And this is the carry when to 8-bit or 16-bit, whatever may be. Let's suppose it is 8 bits. So to 8-bit number is added. It may be happen that ninth bit, that means carry bit, is generated. So that carry is signifies this bit C. When carry is generated, C is 1. When carry is not generated, C is 0. Let me show you that. Let me show some basic register and flag operations. So we already know this program MVIA03H, that is move immediately 03H the data to accumulator. So let me few write some few code here, that is MOV move B to A. Now go to file and save it. I'm gonna save it in D and assembly language tutorial, and I'm gonna name it prog 2 dot ASM. Remember, ASM stands for assembly language. Now save it. Now for executing this, you already know. To execute that, you have to go to assembler and click on execute. Another way of executing in step by step, that is, go to debug and click on step in, or you can just click on F5. So I'm gonna click on F5. F5. So this blue line indicates this is the instruction to be executed. So after executing that, what will happen? Let's see. So here it is. After executing MBI A03, the accumulator content is 03, and now the instruction is on MOV BA. What is MOV BA? MOV stands for move, and BA here it is in opposite direction. Here B, here the content of A is transferred to B, but you have to write it in reverse direction, that is B comma A. That means the content of the accumulator is storing into B. So execute it, and here it is. You can see that the content of B is also changed in 03. Now let me add some more instruction, some basic instruction, like um, okay, this is okay, that is it. So let me reset it. Not resetting. Okay, just close it and restart it. So close, restart. Now write a code again. That is, what is our previous code? That is MVI A03H. Okay, then MOV B2A. Now add a code SUB B and HLT, halt. Now control save it. I'm gonna save it again in assembly language tutorial 2 and just replace this, and this is it. Now again, 5 F5 stands for the debug step in menu, so I am pressing F5. Now the instruction MBI and move have completed. It is pointing on sub B. So you can see that A, the means the accumulator content is 03, and the B content, or the content of the B, is also 03. Now SUB, what is SUB? SUB stands for subtraction B, that is, subtract the content of B from the accumulator content. So when you execute it, the content of accumulator becomes 0, and you can see that parity shows 1 and the 0 counter also shows 1, as in the accumulator content is now 0, the 0 counter is 1, and there are even number of zeros, so the parity also shows even number of 1. That means 1, sorry, 1, that is the accumulator content, parity content is even. Now let me just rewrite this code, or just what. Okay, that's all for it today. Keep watching these videos, and I will be making more videos on it, on this tutorial. So see you guys, and thank you for watching.